Hey guys, I'm going to go over Calc-Medic, the Unit 3 10 multiple choice. Okay, so let's just get started here. Okay, first one, we just want a derivative. We were looking for f prime here, right? So if we have the derivative of 2x sine squared x, well, this is going to be quotient rule. Also, I did these questions beforehand to make sure I remembered how to do them. And so I did get one of them wrong because I missed a minus sign, but that's why the answers are already down there. So let's do quotient rule, right? So we can, with quotient rule, the derivative of quotient rule, right, where we get f of x times g of x. That's equal to f prime times g plus g prime times f. Okay, so if we have f prime as 2x, well, the derivative of f prime is just 2. And then we just leave g prime alone, which is sine squared x. If we have g prime, well, g prime is sine squared x. So we use chain rule. So we use power rule to bring the 2 out in front of the sine x and reduce sine squared x's sine squared power down by 1. And then we have to take the derivative of the inside of sine, and the derivative of sine is cosine. And then we have to multiply that by f of x, which is times 2x over here. So basically we get 2 sine squared x plus 4x, because we have the 2x over here. We have the 2x over here. I'm sorry if that's hard to read. Times the 2, so that's 4x sine cosine x. Which is the correct answer here. Right? So again, answer here shows that we have to use the product rule to get our answer. Okay, so on to the next one. This one, you're gonna have to know some log rules. Okay, so this looks like a very complicated expression. But the first thing I notice here is that E and ln. E and ln will cancel each other out if I make this easier on myself, right? So I have e to the 5 ln of x squared minus x. Well, if I have a to the times ln to the ln of b, well, I can actually make this equal to ln of b to the a power. I can bring the a to the exponent, right? These are interchangeable. A being multiplied to ln of b, well, it's the same thing as ln of b to the a power. So what I can do here is I can make this, I can take this 5 in front of the ln and do x squared minus x to the 5th power. So I took this 5, which was in front of the ln, and put it to made it the exponent because of log rules, and e and ln cancel each other out. So I get f of x is now just equal to whatever's left, which is x squared minus x to the 5th power. Now, taking the derivative of this, chain rule, right? So taking the derivative, well, we do power rule because power rule's on the very outside. So we take the 5 out, we get x squared minus x to the 4th because we reduce the power by 1, and we take the power outside because of power rule. And then we have to take, due to chain rule, we have to take the derivative of the inside. So, right, this symbol means derivative. Derivative of the inside. So the inside is x squared minus x. So when we take the derivative of the inside, we get 5. We still have this 5x squared minus x to the 4th. But the derivative of the inside is 2x minus 1. Right? Derivative of x squared. Again, that's power rule. We decrease the power by 1, bring the power to the outside. It's 2x. Derivative of minus x, well, derivative of x is 1. So it's going to be minus 1. So we're going to get an answer here. We get the 2x minus 1. This is our answer right here. Okay. You can't escape trig derivatives. You're going to be tested on this. So, first off, what does this mean? If I take the derivative of a function, y, right? If I take the derivative of y, let's say derivative of y equals x plus 1 or something, right? That's our initial equations, y equals x plus 1. Well, I'm going to get dy dx. Right, and on the other side, well, the derivative of x is 1. Now, so you can see how the y, because it's in the numerator, just becomes a dy dx. If I take the derivative again, well, there's going to be 2 x's here. Well, there's going to be 2 d's, so it's going to be d squared here. There's still only 1 y, and there's going to be 2 x's down here. And so that's how they get this notation. And in this case, the derivative of 1 is just 0. But when you see this here, all this means is the second derivative. So that means I have y equals secant x. I need to take the derivative of this with respect to x. Right? So derivative of secant x derivative of y with respect to x is just dy dx. Derivative of secant x this is something you have to memorize. It's secant x tangent x. Now, when we take the derivative again, we have product rule. So, derivative of secant is already secant tangent. Multiplied again by tangent. Actually, I should write this out. So let's say f of x is equal to secant g of x is equal to tangent. Well, product rule is f prime times g plus g prime times f. So f prime here is going to be equal to secant tangent g, because that's equal to tangent x, g prime. The integral of tangent is secant squared. If I knew how to write. So f prime is right here. G, right, because g is just tangent, so that's right here. Then we're going to go to the second part. G prime we determined secant squared. And then f is just going to be secant. F is secant g prime is secant squared. G is tangent of x. And then f prime is secant tangent right here. Okay. And so that leaves us with secant x times tangent squared x plus secant cubed. Which is the answer right here. I'm going to test my audio real quick. So I'm just going to pause recording. Okay, it should be recording again. Okay. So next question. Looks like we got another chain rule, but this is with inverse trig functions. So remember, first thing, how do I want to do this? First thing, inverse tangent of x is the same thing as arctangent of x. So those are the same thing. Inverse tangent is the inverse of tangent. It is not equal to, it's not equal to tangent of x to the negative 1 power. Let me just put that in red. This is not correct. Okay? This negative 1 here means it's inverse tangent, which means it's the opposite of tangent. Now, you should know that derivative of inverse tangent This is something you're gonna have to memorize, is 1 over 1 plus x squared. So if we have something a little bit more complicated than that, we're gonna have to use chain rule, right? Because there's a function inside a function. If you guys have never seen Tropic Thunder, there's a dude playing another dude. That's a great movie. But it's kind of like that. There's a function inside a function inside a function. So this e to the 2x is inside this inverse tangent. So we get this 1 over 1 plus, but instead of this x here, we have this e to the 2x, right? So we're going to have e to the 2x squared. So instead of x squared, we get e to the 2x squared. But now we have to do the derivative of the inside. So what's the derivative of e to the 2x? Well, derivative of e to the x is just e to the x. So the derivative of e to the 2x is going to be e to the 2x as well. But there's another function inside, right? So now we have to do derivative of 2x. Derivative of 2x is 2. So we took one function, which was tangent, the inverse tangent. Derivative of the inverse tangent is this, right? Derivative of e to the 2x, well, that's e to the 2x, because we had to take derivative of the inside. Derivative of 2x on the very inside is 2. And finally, we are done. We've taken every single function, because there's nothing inside of 2x, right? Derivative of 2x is just 2. So from here, you just simplify, and so you get a 2 e to the 2x all over 1 plus e to the 2x squared. Well, exponent rules. If you get an exponent to the exponent power, you can just multiply them together. So 2x times 2 is 4x. And so that's how we get a. And just to clarify a little bit more, e to the 2x squared, when we have an exponent to the exponent power to another exponent, right? We have e to the 2x squared, right? So it's to the 2x power to the squared power. We can just multiply the exponents together. 2x times 2. So we get 4x. And that's how we get this 4x here. Okay. Let me just... Okay, I'm going to move on to the next one. These are difficult, by the way. Even I didn't get every single one of them correct. So I had to look up how to do at least one of them, because it's been a while since I've done this stuff. But don't worry. You practice this enough, you'll get it. There's a lot of online resources for you to use. Okay. Now this one was one of the two that I had to look up how to do, because I couldn't remember exactly. But just like how inverse tangent -1 is inverse f to -1 of x, that means inverse, right? So if f of x happens to be e to the x, well then the inverse f to -1 of x is going to be ln of x, because the inverse of e to the x is ln of x. Okay, what if you're confused by that, right? You don't know e to the x is inverse of ln of x. That's no problem. So we just took y equals e to the x. and we wanted to find the inverse, well, we just have to solve for x. And to get rid of an e, we have to ln both sides. And so we get ln of y equals ln of e to the x. And ln of e is 1. So you get ln y equals x. And so the inverse of this is just switching it. So ln of x is equal to y. So this would be the inverse. I'll do it in red, the dark side, compared to the good side, right? Like in Star Wars. Maybe I should have a green lightsaber instead. Okay. So, also just to show you guys graphically what an inverse means, right? If we're to take e to the x, the graph of e to the x looks like this. The graph of ln of x looks like this, right? This is ln of x here. And then this is e to the x. We know they're inverses because they mirror each other. If you mirror them along the line y equals x, right? So this is 0.01 on the line. And the inverse of that is going to be 1, 0. The inverse of, let's say this point's 3, -3. Or actually, I'm going to make this -2. The inverse of 3, -2, you go along to the other side here. Well, that inverse is going to be -2, 3. Okay, so I just did like a whole explanation on inverses, and it's going to be useful for this problem. Because if f of -1 is equal to 3, right? In other words, we have a point -1, -3. Well, the inverse, so this is function f. So the inverse, right, f of -1, which is equal to g, because that's what they gave us. That's equal to g. It's going to have a point -3, -1. Okay, because if it's the inverse, well, it's going to, if 1 has a point of -1, -3, well, then the inverse is going to have the inverse coordinate, -3, -1. Okay, so if we want to find g prime, right, well, a couple different ways you can do this. Let me just take a look at something real quick. Okay, so we know that for an inverse function, g of f of x is going to equal x. Because for the normal function, g of x equals f of x, then the opposite is going to be g of f of x equals x, right? So when we take the derivative of this, we use chain rules, so we get g prime of f of x times derivative of the inside, which is f of x, and derivative of x is 1, right? So this is when we take the derivative of this function. Okay, so we want to find the value of g of -3, right? So if we want to find that, then we need to, because -3 is equal to negative, how do I want to put this? Because -3 is on function g, we actually need to use -1 for f, because that f is the inverse of g, right? So we're going to plug in -1 for x. And if this math is like a little bit too much for you guys, don't worry, I have an easier way to solve it. I'm just kind of showing you graphically how this works. Okay, so f of -1, well, f of -1 is -3. So we get our g prime of -3, which is what we want, because that's what we want to solve for. That's the whole reason why I use f of -1, because we know that f of -1 is equal to -3. So all we need to do is find out what f prime of -1 is. So let's find out what f prime of -1 is. So I'm going to erase this all up here. Don't worry, the questions on the back half are a little bit easier. Let's take, so f of x equals x cubed plus 2x. So f prime of x, well, we're just going to be utilizing power rule, right? So you get 3x squared plus 2. You plug in -1, f prime -1. Well, you get 3 times -1 squared. Well, -1 squared is just 1. That just cancels. Plus 2. So f of -1 equals 3 plus 2, or 5. Okay, so we plug this into here, and I'm just going to move this up here. G prime of -3 times f prime of -1, which I forgot to put a prime here, which is 5. So we're going to multiply it by 5 to plug in for f prime of -1 is equal to 1. So we divide 5 by both sides, we get g prime of -3 equals to 1 over 5. And that's how we get an answer for C right here. That was a lot of complicated math. You know, I had to look up power to do this one because it's been a while. I solved this intuitively. I solved this with a graph, because I know that when it comes to inverses, oftentimes it's just taking, when it comes to inverses, the slope is normally, when it comes to inverses, the slopes of the two graphs are going to be 1 over each other. So we know the slope at -1 is going to be 5, right? So at the point -1, -3, the slope is 5, right? So this is for f. So for g, which is the inverse, at the point, remember, we have to reverse the coordinates because it's the inverse, -3, -1, the slope is going to be 1 over. So it's going to be 1 over 5. And if you want to test this, you know, as ln of x goes to infinity, it gets closer to a slope of 0 here. But on the same point over here, this slope gets closer to 1 over 0 or infinity. And the same thing down here. This slope is close to 0. This slope is close to infinity because they're just 1 over each other. So I'm going to clear this, but that's how you get the answer C. That was a complicated one. Don't be afraid if you didn't get that one. So, kind of briefly go over. They found f of -1 by taking the derivative, finding that it's equal to 5. And basically, because g of x is equal to the inverse of f of x, well, if you want g to -3, well, you have to use -1 here, and it's just 1 over the slope of f. So if you want to find the slope of the inverse, you have to take 1 over the slope of the other function. And because the other function slope was 5, well, the inverse slope for g is going to be 1 over 5. You just have to make sure that you flip your coordinates. Okay, another inverse trig. You can't escape. I'm sorry, you can't escape these inverse integrals. So if you normally have a derivative of inverse sine, well, that's going to be 1 over square root of 1 minus x squared. And I'm just going to make sure that I remember it right. I'm pretty sure that's it. Yep, that is correct. So, unfortunately, we don't just have inverse sine of x. We have a function inside a function, right? So, the derivative of inverse sine of ln of x, well, it's going to be same thing for the most part, 1 minus, but in this case, instead of x squared, because we don't just have an x, we have an ln of x, we want an ln of x squared. And we have to take the derivative of the inside, right? Because we took the derivative of the outside, which is the inverse sine. Now we have to take the derivative of the inside. So derivative of the inside of ln of x, derivative of ln of x is 1 over x. And so when you multiply these together, you get 1 over x times 1 minus ln of x squared, which is b. Okay. Kind of explains exactly where I went with this. This is the one I got wrong. I missed a negative sign here. Always missing a negative sign can be so crucial sometimes. So if you see something like this, we got x's mixed with y's, y squareds, you have to be thinking implicit differentiation. Okay, so if we want to take the derivative with respect to x of this equation, x minus 2xy minus y squared equals 2. Okay, so derivative of x with respect to x is just 1. Derivative of, I'm going to have the minus 2 out in front. Derivative of xy, well, derivative of x is just 1, and then you leave y there, plus derivative of y, well, that's actually, derivative of y with respect to x is going to be dy dx, right? We can't get rid of that with the x, and the x is going to remain there. Just making sure I'm doing this right. Yep, okay. And derivative of y squared, well, okay, we got a power of 2 on the outside, so the outside function squared. So we take that out, reduce the power by 1, we get 2y, well, and the derivative of the inside, what's the derivative of y with respect to x? Well, that's going to be dy dx. This is how I implicitly differentiate. I know there's a slightly different way to do it. You do get the same answer, but this is how I end up getting it, so let me know. Derivative of 2 is just 0. So from here, we get 1, let's see, 1 minus, okay, so the 1 gets canceled out, so you get minus 2y plus, and this is where I messed up. I forgot to distribute the negative to both. I forgot to distribute the negative to here. I put a positive before. So you get 2x dy dx. And then minus 2y dy dx. This is equal to 0. Okay. Now, normally you would just solve for dy dx. A lot of times questions will ask you to solve for dy dx. In this case, no, it doesn't ask that. It asks, what is, when x equals 1, what is dy dx equal to? Okay, so they've given us x, but we're still going to have this y in the equation here. So we actually need to solve for y by plugging x into here, right? So if we have x minus 2xy, oh my gosh, I can't write at all. Okay, x minus 2xy minus y squared equals 2. Well, if I plug in 1 for x, well, I get 1 minus 2 times 1 times y minus y squared equals 2. Well, I get 1 minus 2y minus y squared equals 2. We have a quadratic. When we have a quadratic, we want to make sure that one side of the equation is equal to 0. So we're going to subtract 2 over. And when we do that, we get negative 1, because 1 minus 2. So just subtract 2 to both sides here. So we get -1 minus 2y minus y squared equals 0. If we take the negative out, we get a -1 times y squared plus 2y plus 1 equals 0. Okay, and because of the fact that this is just equal to 0, we divide -1 from both sides. This -1 just disappears. So y squared plus 2y plus 1 equals 0. Luckily, that is very easy to factor. If we can get the right color, that's just y plus 1 squared equals 0. So what does y have to be for this equation equal 0? Well, y has to be -1. And when y is -1, -1 plus 1, 0, 0 squared, 0. Finally, we have x equals 1, we have y equals -1. We can plug in, find dy dx. So let's plug those in. 1 minus 2 times y, so y is -1. Actually, I do want to, before I do that, I do want to solve for this. So before we plug in, let's just solve for this for dy dx, just to make it a bit cleaner. So you get 2y minus, I can take the dy dx out here. And so minus, and I get, because the minus is distributed, I just get 2x plus 2y. And then from here, now it becomes a lot easier to solve. If I subtract both these over, I get dy dx is equal to, hold on one second. Dy dx is still being multiplied 2x plus 2y. So if I subtract the 1 over, add the 2y over, 2y minus 1, and then I can divide the 2x plus 2y over. So dy dx is equal to, just make sure I'm doing this right. Okay, perfect. So you get 2y minus 1. This is a question I got wrong because I forgot to distribute a negative sign, so I'm just making sure. So, even someone like me who's been doing math for years, we can mess up sometimes. So now we have 2y minus 1 over 2x plus 2y is equal to dy dx. We can plug in our values here. So when we plug those in, we get y is -1, so -1 here, minus 1, 2x, so 2 times 1, plus, so y is -1, so 2 times -1. We get -2 minus 1. We get 2 plus -2. So we get 3 over 0. 2 plus -2 is 0. We can't ever get anything over 0. If we get something over 0, that's not good. This is actually non-existent. Because we get a 0 in the denominator, that does not compute, does not exist. So that's why I get the answer of E, non-existent. And now you know how to do the problem that messed me up. So this just shows when x equals 1, it's solved for y. We got, just plugged into this equation so that they can get y plus 1 times y plus 1. So y is equal to -1. So we need to find the slope. So they implicitly differentiate here. And that's how they basically follow the steps I did. Implicitly differentiate. And in this case, didn't actually solve for dy dx, but they ended up getting 3 equals 0, which same thing kind of is getting 3 over 0, which isn't true. So dy dx non-existent. Okay, so let's move on to the next one. Okay, these last couple aren't too bad. So which of the following functions would quotient rule be considered the best method? Okay, so quotient rule, we want to use quotient rule. So this is going to be guess and check, right? Is this one good for quotient rule? Well, we could use quotient rule, but it's not the best method because every single one of these is I can take out a 2x from. So I could rewrite this as 2x x squared minus 2x plus 3 all over 2x. And so these 2x's cancel. And you're just left with x squared minus 2x plus 3, which is a lot easier, and you don't have to use the cumbersome quotient rule. What about inverse sine of 2x? Well, this is inverse sine. It's not sine to the negative first power, right? Because it's inverse sine, there's no quotient here. So we wouldn't use quotient rule for inverse sine. So just remember that the sine -1, that is inverse sine, not sine to the -1 power. Okay, so quotient rule does not apply here. 1 over x squared, we could use quotient rule, but this is just equal to x to the -2. And it's pretty easy to just use power rule here, right? So derivative of this, well, the power is going to be 1 less, so you get -3, and you bring out the -2 to the front. We don't need to worry about doing the long process to do quotient rule. D, sine x over 2x minus 1. Well, sine x and 2x minus 1, they can't simplify, right? We have a quotient. There's no way to get rid of this quotient, so D is actually going to be our answer. E, for the same reason as C, E is just going to be chain rule because we're going to just use power rule, which with power rule, we get -3 out to the front, x squared minus 25 is still inside, right? The power goes down by 1. And then you just take the derivative inside, and the derivative inside is just 2x. We don't need to worry about quotient rule for E. This is the only one where it actually is the only way, quotient rule is the only way to solve for this. So sometimes don't be afraid to guess and check. Sometimes it makes a question a lot easier. Okay. So all these answers are just point A, B, C, D, or E. So we just have to figure out which of these points is the answer to this one. Okay, so this is f prime, graph of f prime, which is the derivative of f. They want, which of the following points is f prime, f double prime? So they want the greatest value of f double prime. They want the greatest value. Okay, so f double prime is the derivative of f. Or sorry, f double prime is the derivative of f prime, right? So if we go from f to f prime to f double prime. Well, if f prime represents the slopes of f, then f double prime represents the slopes of f prime. So if we have the graph of f prime here, and we want the highest f double prime, well, f double prime is just the derivative of this graph, right? Because we have f prime, we only have to do one derivative to get f double prime. So if f double prime is the derivative of this graph, then that means we are looking at the slopes of this graph and seeing which one the highest slope is. So slope of A, pretty small, right? It goes, it's, you know, probably at least -5. At B, the slope's 0. So f prime, just 0. C, slope is 0 here too. Slope at D, 0. Slope at E, that's really high, you know? This is, E is going to be your answer here. E has the highest slope. Because f double prime just represents the slopes of f prime. So when f double prime is the greatest value, well, E is where the highest slope is. Okay, last one. Okay. More trig. I'm sure you're excited about that. Okay, so it says, what is the equation of the line to the graph y equals secant of 2x at x equals pi over 2? So they want the line tangent to the graph of y equals secant 2x. Well, a tangent line is going to be a straight line, so it's going to be y equals mx plus b. That's going to be our answer of some form, y equals mx plus b. So all we need to do, right, it's going to be an equation of y and x. We need to find out what m is, what is m, and what is b. Okay, so let's start out with getting a point. An easy way to get a point here, they've given us that x is equal to pi over 2. So we could solve for y immediately and get a point, right? If we get a point and a slope, we can get point for slope form, right? And then we can find our equation that way. So let's plug in. And I'm going to use blue. I don't like using red. So let's plug in our x. So y equals secant of 2x. So when we plug in our x, our x is pi over 2. You might be thinking, I have no idea what the secant, and you know, the 2's cancel out. I have no idea what secant of pi is. And I would say, yeah, you don't need to remember what secant of pi is. Right? We have to remember secant is the reciprocal of cosine. So secant x. Ooh, my back. Oh, my back's getting a little messed up here. Okay, let me just stretch a little bit. Secant of x is equal to 1 over cosine of x. Okay, so I don't know how that happened. If y is equal to secant of pi, well, y is also equal to 1 over cosine of pi. And what is cosine of pi? Well, from your unit circle, you should know that cosine of pi is -1. So we get an answer of -1. Y is equal to -1. Okay, so now we have our point. We have a point of pi over 2, -1. So we half the battle, right? We've taken care of half the battle. We have a point, and using point slope form, we can, point slope form being y minus y1 equals m x minus x1. We already have x1 and y1. So now all we need is m. And whenever you hear slope in calculus, you have to think derivative. Okay, so we need to find the derivative of this. All right, so derivative of secant of 2x. Well, derivative of secant, need to know is secant tangent. So we have to keep the 2x, remember, inside. Right, that's the derivative of secant tangent. And then the derivative of the inside's 2x, so derivative of the inside is just 2. Okay, so 2 secant now of 2x, right? So we're going to plug in pi over 2 now, right? Because we want to know the slope, right? Because this is our f prime, which is going to equal to our slope at pi over 2. So we're going to plug in pi over 2 here. Again, that's going to cancel. Again, pi over 2. That's going to cancel. Okay, so we get 2 of secant pi and then tangent pi. Okay, we already figured out what secant pi was, right? Secant pi we solved up here. Secant pi turned out to be -1. So we get 2 times -1. Tangent pi is a little bit more complicated. From the unit circle, they do give you the tangent values, but I often like to just memorize sine and cosine. We know that tangent of x is equal to sine of x over cosine of x. So tangent of pi is going to be equal to sine of pi over cosine of pi. Right? Because tangent is equal to sine over cosine, so tangent of pi is equal to sine of pi over cosine of pi. Well, sine of pi is actually 0. Cosine of pi is -1. But this whole thing just becomes 0, because anything times 0 is 0. So we get a slope of 0 for our line. So if you're looking at a graph, right, you got a graph up here. The slope of 0 is just a straight line. And we know that y is equal to -1. So actually, our line is going to be at -1. So this is going to be our tangent line. So that's how we get y is equal to -1. Because we found that our slope is 0 at x equals pi over 2. That's so the line tangent to it's going to have a slope of 0. And where x is pi over 2, y is equal to -1. So the tangent line is just going to be y is equal to -1. And then, right, so they solved so that pi over 2, when you put in x equals pi over 2, the point is -1. And they solved for derivative. Tangent of pi is equal to 0. And there you go. So that is Calcmedic Unit 3, all 10 multiple choice. So I will post this on my YouTube.